All right, for this video, let's go over a function, what it is, and how to identify whether or not the set of data you got is a function. So we've got a function is a special type of relation that pairs each domain value with exactly one range value. That is extremely important. In other words, the same x value cannot have more than one y value. X values cannot repeat. Make sure you write that down. X values cannot repeat for functions. So I like to think of it as this little machine right here, all right? So first of all, we've got this little chunk of data right here. So I'm going to plug some stuff into my machine, and I'm just going to see what it spits out. So first of all, we've got our x values are always going to be what goes in. X is our input. So I've got a 1, plug in a 1, and it spits out a 4. Or nope, it spits out a 1. I am so good at numbers. All right, it spits out another 1. Next up, you plug in a 4. I'm just going to turn this 1 into a 4. And what's it going to spit out here? It spits out another 4. Oh, okay, so far so good. We haven't repeated any x values yet. We've only had the same number for x and same number for y. But because it's not both x, we're all right. Next up, I'm going to plug in an 8, and it spits out a 1. Looks like we're still okay. I haven't repeated any of those things I'm putting into the machine. And an 11, and it spits out a negative 3. Excellent. All right, no problem. So is this a function? Well, I would say yes, because none of our x values repeated here. Next up, we've got that, what was it, a map diagram?
Mapping diagram.
Mapping diagram. So now we've got a mapping diagram. We're going to do the exact same thing. The very first thing that shows up for the x is a 1. That is what I'm plugging into the machine. Now the mapping diagram has these arrows to show us what comes out of this machine. First of all, it's going to spit out this negative 4. Nice, no problem. Cool, but oh, hold on. It looks like it has 2 arrows attached to it. That means I have to plug 1 in again, and I think you already know where this is going. Next up, it's going to spit out a negative 1. Okay, well, oops. Now it's going to spit out a negative 1, which means we have just plugged the exact same thing into our machine, and it spat out 2 completely different things. It's like pushing the same number in a vending machine, and it spits out 1 candy the first time and a completely different candy the second time. That thing's not functioning. So I can already tell this is not a function. All right, so let's try another one. Now we've got a bunch of ordered pairs. All right, so we've got our x values and our y values. We're still going to plug in the x values and see what y values it spits out. So first up, it's going to plug in a 4. Into this machine goes a 4. What's it spitting out here? Well, it's spitting out a negative 3. All right, cool. That's a 4. It's spitting out a negative 3. Cool. Next up, it's going to plug in a 3. Should I do this further?
Input 3.
Input 3. And now let's see what spits out. Well, that's going to be a negative 5. Okay, cool, cool. So far we haven't repeated any x values. We've got that 4. We've got that 3. Next up is a 2. And the output becomes a negative 5 in this case as well. Ooh, interesting. Does it matter if we have the same output? Not particularly. What matters is if it has the same input, the same x value. So we're still okay. Next up, we've got a 2. Uh-oh. We just plugged in a 2. We've got the repeated 2 right below it. Well, the first time it spit out a negative 5, but it looks like the second time it's spitting out a negative 4. Once again, this machine is giving us 2 completely different candies for the exact same button, so
I wanted a candy bar. It gave me a Twix.
Twix is a candy bar.
It's not a chocolate candy bar, it's a chocolate-covered candy bar.
Mr. Craig might be a little confused about his candies, but yes, the point is the same. This machine is not functioning. This thing gave us 2 different answers for the same input, and so no, this one is not a function. So far we've got, yes, this is a function, no, this is not a function, no, this is not a function. And last one. Let's do the same thing again. Now we've got our input as 8, and it's spitting out a positive 2. That's promising. All right, next up, negative 4, completely different input. 4, and it's spitting out a positive 2. Again. But again, that's what it's spitting out. It does not mean it's not functioning. We've got 2 completely different numbers going in. We have 2 completely different x values. We're still okay. Next up, negative 6. And it's going to give us another 2. Oh, weird. But again, we're not repeating the x value, so we're still fine. The last one, positive 1. It's also giving us a 2. But still no repeated x values, so we're still okay. This one is a function. It is functioning. All right. All right, pause the video right here. Try this one out for yourself. Okay, is this given set of points a function? But first of all, let's figure out what the domain and range is here. You should have watched the other video for that. Domain. All right, now let's list out all of our x values, because that's our domain. We've got negative 29. We've got a negative 1. We've got a 3. And we've got a 52. None of these repeated. That was worse than Mr. Nelson's funky chicken. There we go. All right, none of our domain has repeated. So far, we're okay. I can immediately tell at this point, by the way, that this is going to be a function. None of this is repeated. None of that has repeated. Yes, this is a function. But while we're here, let's go ahead and finish up the range too. And, oh, hey, look, we only have one answer. So there's a couple different ways we can write this, just like the other video said. We've got the range equals. You could just put a 0. Oops. If you can write a 0. There we go. We've got the range equals 0, or the range, and you can still put the funky chicken. It's not wrong.
The range is the set that contains the number 0.
Exactly. The one number, which is 0. All right, once again, pause. We've got the given set with this bunch of ordered pairs, so let's go through and list the domains again. We've got domain, funky chicken. All right, first one is a negative 2. And second, oh, hey, look, the second one is also a negative 2, which means I don't put it twice in my listing of the domain, but I can tell right now that this is not a function because I've got a repeated domain. But let's continue with our answers here. Negative 2 does not need to be written twice, so we've got that one done and that one done. Next is a 0, and last is a positive 2. All right, excellent. Range is going to be all of our y values, so range is, let's see, we've got a 0, a negative, oh, hey, look, this one is not quite in order. We've got a 0, a negative 1, a negative 2, and an 8. This means we have to rearrange it ourselves so it is in numerical order. We've got a negative 2, negative 1, 0, and an 8. There we go. All right, once again, pause. And let's go. So for this one, domain and range, starting in the same way, domain, funky chicken. All right, our first x value is a 1. Our next x value is a 4, and an 8, and an 11. And once again, right here, I can identify that I did not have any of my domain numbers repeat. So yes, this sure is a function. All right, now let's finish it up with range. So for range, first of all, let's see if this is in numerical order this time. We've got a 1, a 4, a 1, and a negative 3. It is not. So I'm just going to make a list of these numbers so I can keep track of them. And now let's list them in numerical order. We've got negative 3, comma, 1. I have 2 1s, but I only need to put 1. And then a 4. That was also a weird funky chicken. We're getting all kinds of weird right funky chickens. That was a super chicken. All right.